Laws of reflection of sound. When sound travels in a given medium, it strikes the surface of another medium and bounces back in the same medium. This phenomenon is called the reflection of sound. The reflection of sound follows two laws. The first law states that the incident waves, reflected waves, and the normal at the point of incidence lies in the same plane. The second law states that the angle of incidence is equal to the angle of reflection. Here our aim is to verify the laws of reflection of sound. Materials required: alarm clock as sounding body and reflection of sound apparatus. This apparatus consists of two cylindrical hollow tubes, a sound reflecting surface, and a protractor. Procedure: first, move the lower end of tube 1 towards the right at an angle of 20 degrees on the protractor. Now, take an alarm clock and place it at the mouth of tube 1. Allow the sound waves from the clock to pass through tube 1. Now, move the lower end of tube 2 to catch the sound waves from tube 1. Fix tube 2 at an angle at which the sound is distinctly and loudly heard when the ear is placed at the mouth of tube 2. Note the angle of incidence and the angle of reflection. Here, both are 20 degrees. Move the lower end of tube 1 at an angle of 40 degrees on the protractor and position the clock at the mouth of tube 1. Move the lower end of tube 2 to catch the sound waves from tube 1. Once the maximum volume is obtained through tube 2, fix the tube at an angle. Note the angle of incidence and the angle of reflection. Here, both are 40 degrees. Repeat the experiment for different angle of incidence to get corresponding angle of reflection. In all the cases, the angle of incidence and the angle of reflection are found to be equal, which verifies that the angle of incidence is equal to the angle of reflection. The tube 1, tube 2, and the normal of the reflecting surface lies in the same plane of the protractor. That is, the incident waves, reflected waves, and the normal at the point of incidence lies in the same plane, which verifies the laws of reflections of sound.